Hi, this is Dr. Rivera, and today I want to give a really quick little talk about the emergent properties of water, especially in relation to ecosystem diversity. So I want to start out at the very beginning. Water is made up of 2 hydrogens and 1 oxygen. It's sometimes called dihydrogen monoxide if you're trying to be funny. So we've got our hydrogen, or H, and our hydrogen is going to have 1 proton and 1 electron. And then our oxygen is going to have 8 protons, 8 electrons, and it's also going to have 8 neutrons. So it's a much bigger molecule with those 8 big protons and 8 big neutrons compared to hydrogen's 1 big proton. So when hydrogen and oxygen get together, what they're going to do is they're going to share electrons. Hydrogen has 1 electron that it can share with oxygen. And so oxygen is going to have 6 electrons that it can potentially share, but it's only going to share 2 of them with hydrogen. And that's so that oxygen can get its outer valence shell up to the magic number of 8, and hydrogen can get its valence shell, it only has 1, to the magic number of 2. So the electron sharing is going to occur so that they can fill up their outer valence shells. In the case of hydrogen, this is just the smallest valence shell, which holds 2 electrons. And in the case of oxygen, this is the larger valence shell, which is going to hold 8. It's going to put 2 of these 8 electrons that it has total in its inner valence shell, and it has 6 left over for its outer. So hydrogen and oxygen, again, are going to be sharing these electrons. So we're going to have a hydrogen sharing with an oxygen and another hydrogen sharing with that oxygen. And in that way, oxygen is going to get 2 electrons total, and each of the hydrogens are going to get 1. So we're going to have, 2 electrons shared here, 2 electrons shared here, and then the oxygen is going to have more pairs of electrons. So 3 other pairs of electrons that it has, for a total of 8 that it's going to have access to. So all of these electrons are going to basically be making a density around the oxygen and or the hydrogen. So we're going to be thinking about these 2 first. So they're going to be basically zoom around the hydrogen, zoom around the oxygen. Okay, so they're going to be shared between these 2 atoms. Same thing's going to happen with these 2 electrons. These 2 are also going to zoom around the hydrogen and zoom around the oxygen. And so they're going to get shared in that way. But oxygen has a lot more protons on it. Okay, that's why I brought up this proton number. These protons are positively charged. Now, the electrons can move around. They can move around the hydrogen or move around the oxygen, but the protons cannot. The protons are trapped. So the oxygen is holding this heavy positive charge compared to the hydrogen with only 1 proton. And so it's actually going to be exerting a lot of pull on those 2 shared electrons. So the 2 shared electrons are going to get pulled towards the oxygen molecule. So sometimes we'll draw it like this, where we have an oxygen. It's hydrogen over here. It's hydrogen over here. And we can think about this in terms of electron density. So just thinking about those shared electrons, this is my electron density map. They're going to be spending a lot of time around the oxygen and much less time around the hydrogens. Okay. So they spend more time over here and less time around the hydrogens. So what that's going to do is that's going to mean this trapped positive charge that the hydrogen has, it's not always going to be totally neutralized by a full electron. Same thing for this hydrogen. So we're going to give this guy what we call a partial positive charge. So a little partial positive charge here, a partial positive charge here. And our oxygen then is going to have a partial negative charge, because the oxygen only has those 8 protons, but it's going to be seeing more than its fair share of the electrons. And so it's actually going to hold a slight negative charge to it because of the electrons spending so much time around it. When we have a partial positive charge and a partial negative charge, these are not going to be able to form full ionic bonds like we would get if we had a full positive charge on one molecule and a full negative charge on another molecule. Instead, these partial charges are going to form what's called hydrogen bonds. These hydrogen bonds are going to be weaker than ionic bonds typically are, and they're going to be between an oxygen on one water molecule and a hydrogen on another water molecule. And they're going to be what is holding those water molecules together. So when we have these water molecules, we've got a big partial charge oxygen. I'm going to make the hydrogens in blue. And these partial charge hydrogens. So now these hydrogens will be holding this partial positive. The oxygens will be holding a partial negative. That partial negative charge is going to attract another hydrogen to it, and they're going to form what's known as a hydrogen bond. Sorry about that. So this is another water molecule over here. Here's another water molecule over here. 2 H's and another O. And these are also going to be forming hydrogen bonds. Like this. We can have really complicated situations with many, many hydrogen bonds forming. I'm going to just put little circles around each water molecule. So each water molecule is held together with covalent bonds. These are very difficult to break. And the water molecules are each sort of sticky to each other with these hydrogen bonds. These hydrogen bonds are easy to form and re-break. They don't cost a lot of energy either direction, but when there are a lot of them, it puts a lot of structure and stability into the molecule. So a couple of things to note about these hydrogen bonds is that they are not very strong, so they're a little weak, but there are lots of them. And so because there are so many, they become very stable. They make the water very stable and very resistant to changes. They are also very flexible. They're flexible in terms of their direction as well as their length. So they can get longer and shorter, and they can also wiggle around. So that means that the water molecules themselves can be constantly moving without breaking the hydrogen bonds. So this has a couple of consequences for water in terms of its emergent property. The first consequence is that water has a high specific heat. The next is that it exhibits evaporative cooling. And the final one that we're concerned about when we're talking about ecosystems is that it allows water to actually go into a floating form when it's solid. Usually a solid is going to be more dense than a liquid, but in the case of water, the solid is actually less dense than the liquid. So I'm going to stop this video for now, and I'm going to start up a new one in just a minute talking about these 3 emergent properties now that you know all about hydrogen bonds.